And welcome back from the lunch break. So, we are at this point ready to start comparing pixels. Now, while I was on lunch break, my original idea was just to compare the pixels as are. And as I had mentioned when we started introducing this idea, is that you sometimes have hitboxes, And I was thinking about ignoring that, but frankly, because we got to deal with the fact that, for example, we're okay with this overlap, but not this overlap, i.e. point being that we want to avoid, we want to rather limit the amount of pixels to a specific area. I think at this point, we're going to go ahead and implement hitboxes, even though I said we weren't. So, just because that's going to streamline things in the long run. So let's go ahead and get that implemented. I think, so let's see. All right, this is what we're going to do. We are going to make a new module for sprites. We're going to go ahead and move that over. And we're going to have hitboxes be a part of the sprites module, but not in the same. Actually, should not be. You know what? Let's delete that. Move to recycling bin. Put that in there, and then we'll just rename it. What is that? No, don't do that because I'm renaming the file anyway. So, init.py. Alright, there we go. Basically, it was saying, oh, wait a second, if you do that, then all your imports are going to be bad. That's what that was saying down here, which is a very nice feature. I do appreciate that. It's just, we were renaming this to init anyway, which means that it gets called the same exact matter, so our imports are not a problem. So, anyway, so. Let's go ahead and make that hitbox.py module. And we're probably going to need pillow. So from pil import image. This is actually a guess. I don't know 100% sure whether or not this is even necessary, but so we're gonna have a class hitbox. I don't know what exactly we're going to initialize. Actually, we should initialize it with sprite is what we should do. Because the hitbox probably needs a reference back to the sprite. The other option... So it was occurring to me that hitbox could be a subclass of, where is sprite? There we go. Could be a subclass of cosmetic sprite. Probably not, no. No. All right, we're not going to do that. So it does save us a little bit of typing, but not going to be necessary because we're not going to, well, I shouldn't say not going to be necessary. The cosmetic sprite comes with other baggage because it's a subclass of sprite, and that we don't need. That's what I meant by not going to be necessary, is where my train of thought was going. So yeah, this is going to be its own class. The next question is, I know I just said that this could have a reference to sprite. Yeah, you know what? We will go ahead and leave it at that. So self.sprite equals sprite. We'll keep it for right now. There's an argument that it doesn't necessarily need it, that it can just have functions that we can call and pass sprite to it. That is definitely a valid argument. That's a little less object oriented. Oriented. I did say that correctly. The idea being that decouples the objects. That makes this not a unique object, but rather a generalized object. which is why it's slightly less object oriented. There's nothing wrong with that. Let me just throw it out there. There's nothing inherently wrong with that. It's just that we got very object oriented in this module. This object module is very much a higher level object oriented module, and therefore I'm going to keep with that theme. So let's see. For right now, so basically there is a number of things that we could do here. Back to the cosmetic. Part of the reason that the cosmetic makes sense to me is because cosmetic could have an offset. I mean, because cosmetic did have an offset, we could use the offset, and that would give us an offset on the parent sprite to place the hitbox. The alternative is that the hitbox, so there's several different ways to generate a hitbox, right? You could generate a hitbox in a specific shape relative to the sprite. So I'm going to go ahead and draw this one, I think. I did swap the USB hub over to the other extension cable and swap my headphones onto that one. So we're going to see whether or not the USB hub still breaks on the other extension cable. Meanwhile, let me double check because I know I bumped my camera. Preview. Just make sure that it is. Actually, you know what? I wonder if it is more useful to have it going more or less the same direction I am going. That's not something I considered until this moment. I have the camera facing the same direction as I am. I always have it obviously coming from the side and I have to turn the page. So you're off on a little bit of a side right now. Again, you'll get previews of that project that I will be putting up on stream later this week. I talked not last stream now, the pixel art stream last night. I did talk about the fact that I wasn't sure. Let me get this USB cable out of the way. Whoops, bumped. Again, we're trying it at this angle today. So I did talk last night about how the other project I'm working on, I wasn't sure if I was going to put the extra effort in to add a couple extra features to it, and I decided I am. It's one of these things I really should, put the extra effort in just to make it as good as possible. So therefore, it will be getting bumped back. This stuff can't get assembled today, but I need extra parts, which I found out I do not have, on top of putting together extra code, which would be going on that guy, Pro Micro. So in between not having the parts and having to do the extra code, this thing will not be done at this point. By the end of the day, parts won't get in until tomorrow to begin with, and tomorrow, for all I know, late at night tomorrow. And then there's the whole entire, making sure everything works and is assembled correctly. So one of those deals, that guy, like I said, is going to be put off. So, as I was saying, different ways to generate a hitbox. We've got our guy right here. So our guy, maybe if I turn the page a little bit here, it might even help. And you know what? I grabbed this pencil because it was the first thing near me, but let me grab an actual pen. It was useful earlier when... Where's my pen at? Oh, there it is, on the other side of the camera. It was useful earlier when I was screwing up the math here, but at this point, I do want the darker lines. So, here's our guy. Again, we could position a hitbox relative to our sprites. So, for example, we could have several sprites where the hitbox is always, let's say, X number of pixels or otherwise 1/3 or something like that of the pixel width, and then the whole entire pixel height or some portion of the pixel height, and then we just center that on the sprite. So again, even though our sprite's technical bounding box is out here, this is the 32 by 32 that we load in, 32 by 32. So even though we have all this extra space, we could just center it on here and assume that it fits. And by assume it fits, I mean just make sure we design all our sprites so that they are always centered on the page. Another way we could do it is back to, we have this situation with the desk, right? So let me just draw a desk really quick. Rough design of the desk. So we could also, again, this is going to be relative, but we could design it so that here's our box, which again was 45 by 32. Rather than being centered, it could be X number of pixels or X percentage. From the bottom. And that makes sense for what we're doing right now, for having our guys bump into it while they're walking around, but being able to walk in front of behind it without collision. So that's the other thing. So we can create a hitbox just by going all the way across, and that includes, obviously, as you can see, white space, as does this. In this situation, you can see we have all this white space in here. That's fine. We'll deal with that. I'll get to that in a minute. The other way, or another way, so both of these are basically the same exact method, obviously. It's just where you put the area that you're looking at, right? It's just how you align it. That's basically the same method. The other way is to actually have, for each sprite, actually create a sheet. So we've got our sheet of guy walking, right? That is... Alright, he's walking kind of funny. Here. There we go. Extra funny. So, this is our guy walking sheet, right? The other way is actually to take this sheet, make a copy of it, and then actually draw over the pixels with the areas we want hitboxes. And then we just overlap. This overlaps exactly onto our strip because it's the same exact size. And we just use that to extract the hitboxes. So that's the other method. Is just to come in here and actually color the pixels that are hitboxes. For right now, the only thing we really need is maybe these two. But honestly, just this one. So this is just what we're going to implement right now. But maybe in the future, we put a method in and implement this one. Oh, the other thing is... the other thing I should say is that there could be multiple hitboxes, okay? For example, when we had our snake, right? It may have hitboxes that actually look like this. They're squares that are disconnected and are across portions of the snake. Dragon, whatever I call it. I keep on going back and forth between calling it a dragon or a snake or whatnot. So you can have multiple hitboxes. And then there's, one of those things, areas where things will just pass through it. That is definitely a possibility. So you can have multiple hitboxes. And I guess the fourth thing I should mention, fifth thing, whatever nth thing we're on right now. When I say color in pixels right here, technically speaking, coloring this stuff in, you could, in theory, color in a hitbox right here. It doesn't necessarily need to line up with the sprite, strictly speaking. But... Sorry, I just noticed, I think I see a little bit of under extrusion or a layer shift on this thing, which is weird. I don't know why I see that. Okay, it's not a layer shift. It is just in wonky layer. Interesting. Okay. Not sure why that happened. That upsets me a good bit. I'm just going to really check out. The other, sorry to tangent here, it's just back to I spent 2 days straight fixing my printer, and if I got layer issues here, alright, I think it's just the one guy, so I won't worry too much about it. Alright, anyway, so one of those things, it may not make sense to the player, but technically speaking, it doesn't necessarily have to be right on the sprite. So, although I will say, what we will generate for these two guys, actually, that is a good point. Me. This hitbox right here, as I said, we will take care of this, so we won't worry about the white space. You may not want that. You may decide that actually you want to consider this as one solid block. So that is something we're going to have to program in. We may not program it in right now, but we may need to program it in such that instead of compositing the hitbox over the sprite and then only checking the pixels that are basically the mask, treat the hitbox as a mask and then check the overlapping pixels. Instead of doing that, you may want instead to just have a square hitbox that interacts with everything, even if the pixels themselves are not interacting. That is a valid way to go about it, but that's not how we're going to be doing it. So we won't be dealing with that in the code today. So, more coffee. All right, here we have the hitbox self sprite. The other things that the hitbox needs to do is return a bounding box, probably. Yeah, it's going to need to return a bounding box, so let's go ahead and do that. We'll set it up exactly like the other one. Define bbox self. Yeah, so self.offset. I forgot we took a tangent there and I did not put that in here. So we will on the so we can have subclasses just like we have for sprite, right? Where one of them is offset, it has the offset. We could do that. I don't think that makes as much sense on the hitbox because you may decide that the hitbox is offset for other reasons. I can't think of a good reason right now, but the offset is kind of independent of the sprite itself, or of the hitbox itself. You know what? Maybe this is. Let's keep this base class simple, and then I'll make the. We'll do with what we did with the sprites. So. In general, this is what I'm going to do. So, we are going to bring in image chops too as well. Let me pull up the documentation really quick just so I have it on hand because I'm going to need it probably. Get that guy out of my way. You are not on this page. Where did I move? Did I close that already? Or is that on? Okay, I guess I closed Pillow. Wait, where's Piscal? Pillow should be on the same page as Piscal. Did I close both of them? Crap. Okay. I guess I did. Okie dokies. In that case, we'll open Pillow back up. Pillow, read the docs. Read the docs.io. And let's get image chops up. And bbox. Okay, yeah, bbox is part of image, not image chops. Get bbox. There it is. All right, cool. All right, I just wanted to have that available. The next thing. Yeah, so on the base class. I'm just trying to think if there's a default method that we're going to use for everything. Yeah, you know what? We can define this. Self return sbbox equals self. Let's see. S location equals self.sprite.location, and then for bbox we can return I'm gonna do this. I don't know where I'm actually gonna use this method as is, but it makes sense. So as a baseline, like I can't see any reason why it shouldn't be usable in any situation if we want to use it as a baseline, but we may not be specifically using it. So I'm going to go back to here. No, actually, let's see. Yeah, self.image. We're going to add self.image. And that's going to be required. Image. So, sLocation plus self.image dot, or no, so sLocation, shoot. Let me do this. XY underscore return X, Y, X plus self.image dot width, Y plus self.image dot width. There we go. All right, getting back into the swing of it. All right, so there's the basic beatbox. And that is all we really need for the base class, I think. So let's go ahead and make a hitbox subclass. And I am going to call it, let's see, square hitbox is what I'm going to call it. Hitbox, define init sprite image, super sprite image, that's fine. Now we're also going to need an anchor, which is going to be TL, our anchors. Just going to document it really quick. Top right, top TL, top left, TR, top right, bottom left, BR, bottom right, and center. Now the next trick here, just while I'm talking self.anchor, the next trick here is deciding how exactly that works. So let's hop over to the camera really quick. Whoops, sorry. So basically the anchor, I'm thinking, has to be exactly the same on this as it is on the position here. What that means is center of this box has to go anchored center to the top box. So if we have an anchor center, both the mask itself, the square box itself, the hitbox, is anchored in the center, and it's anchored to the image in the center. One of these things, you may need to, if you want it to not work like that, we may need to just implement another subclass. But for right now, it makes most sense. And what that means is, so this mask right here for the desk, this is going to be a bottom left mask, okay? And that means that this mask, and I'm calling it a mask, but this hitbox is going to be anchored in the bottom left. So its coordinates are based off the bottom left, and it is going to be anchored to the bottom left of the image. That way, when we do, and the reason this comes up is if I were to do height and width for this box, so if I took this coordinate, which is the bottom left anchor of our image, let's say this is 0, 10, okay? Well, it's 0, 32. We know for a fact it's 0, 32 in this example. So if I took this coordinate as my starting coordinate, 0, 32, and then tried to draw the box off that coordinate, this would actually go, if this is a 10 pixel box, it would naturally go anchored to the top left instead. That's how you naturally draw things. And that means that it would actually end up below the image. It would end up below the desk, because this would actually be 32 right here, and then the bottom of this would be 42, right? So that is why both the image itself and where it gets anchored are going to be identical to make our life easier. If we want to anchor them two separate ways, we can. Again, we can code that in, but that seems obtuse, and it seems easier just to presume that they're anchored in the same exact direction. So at this point, we need to update property, define bbox self, and now we need to return, well, let me get xy equals self.sprite location. Okay, and then now we need to adjust these numbers based on our anchor. So, best way to do this question, it is a good question. There are several ways to go about it, is the only problem, and I'm not sure which way is best. I'm inclined to make a dict up here called anchor equals, and then put them in here. I just don't know if that isn't too obtuse and unnecessary. I guess it's all right. Okay. So. What if I do this? Here's the other thing. So instead of doing that, we could do top. Let's see. We could do X. Actually, put that up here. Whoops. There. T. None. B. None. And C. We could organize it like this, which is an idea. It's an idea. Because it's an idea and I don't have any particular feelings at the moment, I will just go ahead and organize it like this. Again, this does not take into account 3 dimensionals, but we will cross that bridge and possibly burn it when we get there. Or actually it should be left, right? And we can change this code. I mean, it's a little silly, but all right. So what does that mean? So if it's top, then our X. Actually, no. Top would be Y. And then left, right should be X. Whoopsies. Pretend I didn't make that silly mistake. You saw nothing. You also didn't notice that this is a capital case. Okay. Anyway, top. If it's anchored at the top, then this should be 1. If it's anchored at the bottom, this should be -1. And if it's anchored center, this should be 0.5. What does that mean? What am I doing here? So, this is a multiplier. Actually, I don't know where to put that comment. I guess put this comment up here. Offset multipliers. So, if we are anchored at the top, right, that means that our height, how we adjust the height, the Y, is the same exact number as our height. If we're anchored at the bottom, we are going the opposite direction. So we multiply our height by -1, and that gets us up by a certain number. If we're anchored in the center, then we go halfway down, and then we don't actually draw it there. So the center might be a little bit difficult. I'll have to revisit the center in just a second. We're going to instead continue with the left and right, which are just the actually left is -1 and right is top left top left would be 1, and then right is -1. And I'm gonna have to consider that one really quick, the center one, as we get there. So x off y, let's see. So this works just fine for everything except for center. So does not equal, or whoops, does not equal CC. I'm going to go ahead and handle this separately for right now, and then we'll fix the center one in just a second, just because this is super easy. So our B box returns as, I put the S on there. Actually, this is not as simple as I thought it was, because bottom should be the image height plus. So let us see. Okay, here we go. And this will fix our problem right here. Let me do this, and then that, and then this will be start and width. So if we are anchored top left, the start is 0, or the start is yeah, it's 0. Okay, so this start multiplier, the width multiplier is going to be that, which makes sense. I explained that one already, right? So the width is going to be the same for left, so, and for right it's going to be half. For center, we're gonna again have to handle that a little bit differently, but let's work on one thing at a time. The start, however, this multiplier is going to be based on the height of the, or the width in this case, of the image itself. So it will be image x plus image width times the start. So if we're top left, let's say, the left side, we're going to do x is 0. Let's say our image is also 0, 0. And let's say it's 32 wide. So the start will be 0, because 0 plus width times 0 is 0. So that's still 0. If it's top right, that will be 0 plus width times 1 is what I'll go ahead and add here now. Start 1 with width -1, and I'll just delete that guy out there. So it'll be start 0 plus 1 times 32 is 32, so it will be anchored in top right, and then it will be width of 32 or whatever the hitbox is times -1 to bring us back to the other side. Now I will say that does make our box listed backwards, is the only thing I will say. So for example, in that situation we just had, our output here, if it's top right, actually let's go bottom right just to show you. Bottom right, image is in 0, 0 is where it starts. 32, 32 is, it's here, I'll just type that out so you can see it. At 0, 0 with height is 32 by 32. So these are the parameters we're working with. And our anchor is top right, okay? So the result is going to be 0 plus 32 times 1, so 32. Top right, so the top is going to be, let's just get this typed up really quick so that I can finish the demonstration. Start is 0, width is 1, or height rather. Start 1, height -1. There we go. All right, so top right, so that's 32 on the first one, and then this is going to be start of 0 multiplier, 0 multiplier, so that's 0 plus 0 times height is 0. And then we're going to do the height, or the width rather, the width. We're in the top right, so that's -1. So that's 32 minus 32, 1 times 32 is 0. And then the height is going to be top, so this is 1 times 32. So that's going to be 32. So this is our result. Our expected result, though, is 0, 0, 32, 32. Right. And you'll notice that if we take the offsets right, this is 32 minus 0 is still 32, so that's a width of 32, and 0 minus 32, or yeah, well, 32 minus 0 and 0 minus 32 is actually how it should have been, but it's absolute value because we're just taking the difference, right? We don't care about the negative or positive because we're getting area. So it would be 32 this way and it would be 32 this way, my point being. So we get the correct shape, but the way it's oriented, the way this is oriented, it's not smallest number, top left, to biggest number, bottom right, which is the problem. So the way I've set this up here, one of those things, I was trying to do this in order to streamline the code down here. That is, it obviously does introduce other problems. Point being, that's okay. That's okay. Let's see. Let me just look at the C really quick. Start minus 0.5. Width is 1. Okay, we can do that. So we can now convert this to start minus 0.5 width 1. There's that. And then center on the Y is the same exact thing actually. So or actually, I'm sorry. I don't know why I did. No, actually, it's not the same thing. I take it back. Right. I did minus 0.5, but that is not correct. Height 1. So that is not correct. I'm positive there's a better way to lay this thing out, but obviously I'm not thinking of it right now. So let's just truck along and fix that problem later. The interesting question is, if I put a bounding box into PIL and pillow, will it give me a problem? Let me look at the paste function really quick, just because I know that's asks for a bounding box. See coordinate system. In top or left. Yep, sure. Let's see. And it doesn't say what happens if you pass it coordinates out of order. So let's open up Python from PIL import image. Let's try really quick. My image equals PIL.image. First one is width, is size, right? Or is it RGBA? Actually, it might be RGBA. Let's see. Do. Where is new? There we go. Oh, that's right. It's new. And it is RGBA. RGBA. Then the size, which I'm going to do 100. And the color equals, I'm just going to do 255, 255, 255, 255. There we go. All right, there's my, whoops. Derp. Circle equals image dot new. Well, I'm going to call it a square because that's just easier. New RGBA 25 color equals 000 250. There we go. And then my image dot paste square, and then I wanted to try 25 0 0 25 is what I wanted to try, and square for the mask dot show images do not match. So if I change this back to 0.25, will that work then? Okay, my image dot show. Yeah, okay. So it does care that they are out of order. So we're gonna have to fix that. Clear and minimize. Again, it was probably better to go about this a different way, unfortunately. But. The only thing I'm thinking about now is we could make this with a tuple, but that seems a little bit silly. The reason we'd be doing that as a tuple is to compensate for this. You know what? I realize we just spent half an hour on this one, but probably half an hour. This was ill-conceived right here. So let us just back up and self.anchor equals, and I put this in parentheses because if self.anchor equals top left, return. We don't have an offset yet, so x, y, x plus self.image.size, .width, y plus self.image.height. There we go. elif self.anchor equals top right, return self dot sprite. Actually, right. We maybe want to use bbox instead. I think we do. Self dot, because that makes this part easier. Dot bbox x1 y1. So that would make this one easier, which is x1 minus self dot width, self dot image dot width, y x1, and then y plus self dot image dot height, elif self dot anchor equals bottom left return. This is going to be x y1 minus self dot image dot height, and then this is going to be x plus self dot image dot width and y1. Elif self dot anchor equals bottom right. Again, this was the much straightforward way, the more straightforward way, much more direct way is what I meant to say, way of going about this. X1, and I probably should have just started with it, and I tried getting fancy, and I did not think through everything that needed to happen with that, and that is why we are a little bit behind schedule at this point, because I tried playing with it without actually working through the ramifications. X1 y1, and then elif self dot anchor equals c. I'm going to go ahead and put this back to just c. Return actually x3 y3 equals x1 minus x divided by 2 y1 minus y divided by 2, and then we can do x3 y3 x3 plus self dot image dot width y3 plus self dot image dot width. There we go. And else, or actually we don't even need else here, we can just raise attribute error invalid anchor self dot anchor, and toss the F in there, and off we go. All right, there we go. Again, that was, I mean, that took all of less than 5 minutes instead of screwing around with all the other stuff trying to make it work. Sometimes it's not worth the effort. So that gets us our bounding box. The next thing we may want to do, let's see. All right, so there's a couple things. One, on our find near sprites function, we probably want to change that to use the sprites bounding boxes instead, which is a valid change that we could make. The next thing is that we may want to refactor this to just use let me just put this in here. Define top left at property. Define top left self, and let me copy all this out here. Actually, yeah, I will copy instead of cutting. And we can, these are all the top lefts right here, so I can just delete these out. and keep this rest of this code here. Whoops, wrong place, right there. And right there. And we can also do this, copy this guy down. All right, and copy that up because we're going to need that. And top and left equals self dot top left. And now we can just replace the first thing in all this with those two letters. And the reason this is useful is because the rest of, as we saw just a moment ago, the PIL functions want top left instead of anything else. So this makes our life a little bit easier going forward. And we don't need this over here. Top left, Y1. Actually, if we have the top left, all these just become self.image dot width. Okay, yeah. So that actually simplifies it. I take it back. Return TL T plus self.image dot width. Or that should be L. Okay, let me fix this. So we're returning XY is what we're returning, right? So even though it's called top left, that's actually left top is what it technically is. So I'm just going to return this to XY so that no confusion happens. X, Y, that is actually Y, and then this is X plus self dot. Oh no, I'm sorry. There we go. I knew that was backwards. I just didn't realize I was backwards in the other direction. Self.image.height. There we go. All right. Easy. Easy, easy, easy. And actually, we can refactor this a little bit more. So, at property, define top left self. Return self.sprite.location. Again, just in case this ends up being 3 dimensions, we'll just do the first 2. There we go. And xy equals self.top left. And now we can delete that from down here. Hey, easy, easy. So for the square hitbox, since it's anchored, we just changed the left-right location, and then we're good. Okie dokies. Okie dokies, okie dokies. Again, that took a little bit longer than necessary, but somebody should probably be a little bit better prepared. It's just one of these things. I like the process of working through it, which is why I called this originally the workflow stream rather than tutorials, because running into these roadblocks is part of the demonstration of what's going on here. So I'm justifying it. All right, there's our square hitbox. Again, that's the only one we really need right now because So the next thing that I think I'll put in here is at class method define create square image, create square image class, and then let's see. Yeah, let's just take width and height. We'll keep it simple. So this is just a helper function to return image.new. The mode is going to be 1. We want our images to be, actually, that's a good point. Let's go up here and convert to 1. That way our images are always 1. One of those things again, yeah, I guess I'll put it in here. We don't really want people screwing with this, so we want to make sure that we can always trust it to be 1 of mode 1. In that case, image or at property, define image self, return self dot image, and at image dot setter, define image self value self dot image equals value dot convert 1. Just because it's rather important for us moving forward that this is in mode 1. So anyway, back to this. New so size, yeah, size will be width by height, and let's set these as ints. Int and return image.image, and then color, we want this to be black, so 0000 255, or actually no, I take it back. This actually, if I'm thinking correctly, should just be 0 because it's a mode 1. So, or should it be 1? Shoot. Are pixels in black and white? Pixels in black and white are 1s. Yeah, I think pixels in black and white are 1s. So, I think that is how it's supposed to be. We'll find out. We're going to find out. So, let's actually test it. We can test it. Python from stream animation is one of those things. It autofills everything for me, so that's why I am blanking on it right now. Nice. Dot sprite import hitbox. Is hitbox capitalized? Next question. Nope, it's lowercase. Good. Hitbox dot square hitbox dot create square image, and then we just need the width and height, so 3232 dot show. Okie dokies. So that returned to me, let me hit this button. That returned to me nothing, so let me swap back the 1, and then I'm going to run that again. I'm not going to bother swapping scene for you guys just because it's a quick fix. So let me change that back to 0. And then I'm going to run it, and we got nothing again. Excellent. Excellent, excellent, excellent. Okay, I will swap you back now. So, oh, I take it back. Let me quit first. And then hop back in. Quit, hop back in, and then go up. Hitbox. Show. Alright, there we go. Nice. Alright, here's your picture for you. So there's more square image. And that again is, well, I can swap you back to VS Code, and let me minimize the, So yeah, it was 0. It was supposed to be 0. That was my mistake to get the black. So that is our hitbox at that point. So that's a 32 by 32 pixel hitbox is what we just created in Python. And then we would pass that as image in the square box hitbox generator. All right. All right. Let us go ahead and hop back over to utils and engine. And for this find nearby sprites, this is how I'm going to do it actually. Let's hop back over to sprite instead. And sprite, I'm going to add on self.hitboxes equals list. We're going to go ahead. This seems like something that every sprite should in theory have. Hitboxes is none. Hitboxes equals list. Self.hitboxes, and then for hitbox in hitboxes, self.hitboxes dot append hitbox but first. And I normally don't do type checking, but let us go ahead and add that in right now just because I've already done this. The alternative here is just to do list hitboxes. Okay. Yeah, which we'll do. It's one of those things. I haven't done type checking on anything else, so we're just going to do list hitboxes. There we go. Yeah, I will move this up. I wasn't sure if I was going to move this up, but we will. All right, cool. So now everything accepts hitboxes, and in utils, we can now, for find nearby, we can now check if the sprite has check overlay other sprites, list tuples, sprites. Okay, so this is something I did not fix correctly. You'll recall I copied this down and up in here, and I did not convert this. So at this point, we still have tuples, but we're passing in find nearby sprites. We're passing in sprites instead. So we want to fix that. If sprite is not target sprite, then we want to check overlap for bounding boxes. So TBB box equals target sprite dot bounding box, and let's change this to, that's right, I haven't imported sprites yet. All right, I'm just going to delete these types right now. Okay, and this will be TB box, and actually if target sprite dot hitboxes TB box equal TB box equals, and did that just import whatever I tried to complete there? No. Okay. Equals target sprite dot hitboxes, and we can go ahead and toss this like this. If sprite is not target by, yep, that's good. All right. Now we want to check each hitbox. That's what we're doing right now. We're updating this. I came over here. I don't know if I said that because I got distracted by the fact that we actually screwed this function up last time, being sloppy. But now we can go ahead and do if sprite dot hitboxes for hitbox in sprite dot hitboxes yield All right. So the tricky part here is that this continue right here will continue on this for loop, which is not what I wanted. I wanted to continue on to the next sprite because we've already confirmed. Or actually, no, I take it back. Okay. Yeah. So this is getting a little tricky just because we now have hitboxes and we're checking the hitboxes and the sprite bounding box equally. I think that will be okay, though. Well, we'll just have to handle it, I think. Yeah, that does make it a little bit awkward to handle both the... Alright, so we can avoid this part right here. And list target sprite dot hitboxes. So the way we're going to fix this is by coming back to sprite and changing how we handle no hitboxes, or handle hitboxes in general. So what I was about to do would actually not allow us to have ghosts, which is a little bit of an issue because having ghosts is useful. Yeah, not having a hitbox is actually useful. So this is what we're going to do. This if hitboxes is none thing. Instead, we're going to do actually the opposite. If hitboxes is not none, or if not hitboxes is none, I guess. I mean, it's one of those things. I should be able to do it either way. Hitboxes equals list hitboxes, and then this will preserve the none. So now we know whether or not they're hitboxes instead of me checking the other way. So now hitboxes can be none instead of an empty list. I had it as an empty list just because that makes it easier to iterate over. But since we care whether or not hitboxes exist at all, then we want to sprite target sprite dot hitbox. We want to actually take that as and actually I can change this to list just to be safe. I'm not going to. Instead, what I'm going to do here is if not target sprite. Actually, so the difference now, the implication. Again, there's a tons of implications when you start working with hitboxes, but the implication here now is none the same thing as an empty list? And I am going to say it is for the time being. That may not be accurate, that may not be good, but we don't have a default method for handling hitboxes if target sprite.hitboxes is not none rather. So because we don't, we're going to want to treat it as it has no hitbox, it is a ghost. The sprite is a ghost. So if target sprite dot if not target sprite dot hitboxes, we'll just return. All right, cool. So that is that, and otherwise TBB is that. And then if sprite.hitboxes, so this will handle if there are no hitboxes, which means that we do not need the continue. Well, I'm taking the continue out for actually another reason, and that is that I don't want to skip over. I realized as I was talking the rest of the hitboxes. I want to get every single last hitbox overlap because potentially the pixel-wise comparison between the hitboxes does not actually hit, and I don't want to skip over the rest of the hitboxes for the sprite. So that being the case, for a hitbox in sprite.hitboxes, if check overlap, that and hitbox yield the hitbox. Maybe we should yield both. Oh, that's interesting. Okay. So, fun fact, I automatically record these things in the background. I just got a notification that my hard disk just ran out of space. Fascinating. I'm going to really quick, and I mean really quick, because I don't want that impacting, the stream. I am going to really quick open up the recordings and start moving some off my, because it has been a long time since I moved them over. Let us just grab a handful of these guys now, cut, and paste to external hard drive. Stream raws, where are stream raws? There they are. And paste. And this is what happens when you're a pack rat. Alright, so that's moving up. Hopefully the hard drive functioning right now is not going to impact stream quality. Let's see, dropped frames, any dropped frames? Nope. Alright, no dropped frames yet, so we're looking good. So, anyway, yeah, that was fun. And we will actually do this. And actually, I take it back. This is going to be T boxes instead, and this is going to be T box for TB box rather. In TB boxes. And that is a B right there. So there we go. So yeah, now we will be iterating over all hitboxes. We're returning collisions with all other hitboxes, or close collisions, you know, the check overlap of all other hitboxes, and then returning those as tuples. So find collisions, 40 sprite. The hitboxes, let's just look at this really quick. The hitboxes have access to sprite and image, so they should be able to determine the overlap themselves. And that's going to be the next issue. So I should be able to just return the B boxes. The B boxes are no longer tuples. They are now actual hitboxes. Let me just annotate that over here. Hitboxes. Actually, I can't really. Yeah, well, let's do that down here. Hitbox objects. All right, cool. So again, the next complication here is we are now returning hitboxes which are not tuples, so we need to fix this now, the check overlap. So this so box 1 is going to be self.b box, right? I did this wrong right here too. Wow, okay. This morning stream, evidently not awake. Okay. So, these are hitboxes is what these are. So I'm going to delete those tuples for right now. And then for XY in dot B box, let's change this. Hitbox 1, hitbox 2, box 1 equals hitbox 1 dot B box, box 2 equals hitbox 2 dot B box. I'm going to be a little bit annoying here and just move these around because they look better to me like this. And then this B1 is incorrect for XY in. So this is, in theory, this was the top left corner. The top left corner is 0, 0. That's fine. The top right corner is, oh no, this should be 0, 1. Yeah, 0, 1. The top right corner should be 0, 3. No, that should be, I take it back, 2, 1, top right. Let me just note these: top left, top right, bottom left, and bottom right. Okay, so top right would be the x1, which is 2, and that. Yep, okay. The bottom left is, the x for that one is 0. The y is now 3, and this is 3, and this is 2. There we go. Much better. All right. All right, that should be right, I think. Hopefully I didn't screw anything else up at this point. A little disappointed in myself that I screwed the other stuff up, but that's okay. All right, so now we got to take these overlapping B boxes and get the actual overlap of the images. So the right now we are set up so that our hitboxes, this square hitbox, is just a square that's completely black in theory. We can subclass this again to get a box that is let's see, that is masking the sprite underneath, and that would be that situation where I said we ignore the white space on the sprite and only do the pixels. So let's go ahead and do that. Masked, actually it may just be masked hitbox. I'm trying to think, because you could also do this with other versions. For example, if you import an image and then only want to take the difference or the overlap between the two images. So yeah, and I'll keep it simple for right now. Masked square hitbox. We may want to break this out into another subclass that then inherits from the masked hitbox and the square hitbox equally, but square hitbox, we will deal with that when we get there. So at this point for this one, it functions exactly like this, but when we return image, we want to return the difference between our mask and the sprite. So let's go ahead and do that. That just what that means, sorry, is rather we want to replace this property image. And the only concerning thing I'm having right now is I'm actually not sure, because I've never subclassed a property before, whether or not this one will still work afterwards, which is a little concerning, but we'll see what happens. So the other alternative would be to implement a get image feature, just like we did with sprites. That's not a bad idea, but yeah, we're gonna see what happens. We're gonna see whether or not this breaks it. So for this image, instead, we are going to simage equals self.sprite.getImage. GetImage.convert, and again, we want this in mode 1. We then, let me pull up the docs just to make sure I'm getting this right. It should be difference. Yeah, difference. No, not difference. Do. Shoot, I forgot how I did this. I actually made sure this worked off stream. I thought it was difference, but it's not difference. Dividing the result by the scale and adding the offset. Mode. Logical and? Was it logical and? Permanent logical and on the image with a mode other than 1. Let me really quick. Python pillow. Shoot. What did I... Huh. I think it might have been logical and. I think I might have assumed it was difference at first. But it actually ended up being logical and. Okay, I'm going to assume it's logical and really quick, and it's one of those things we'll do a... I'm feeling kind of stupid for not just saving a piece of... saving the code that I had on this user. It's actually on another computer altogether. I had tried it out just to make sure it worked, and I should have just brought it over here and saved it in a file over here, and we wouldn't be having this problem right now. So... let us see. Self.bbox. So the thing I'm looking at right now is that our square hitbox can technically lay outside of the image. So let's say that we... No. Well, yes. Yes, it technically can. So if we provide it, let's say we're in the top left, right? And we provide it with a width bigger than the image width. Then that sits all the way out past it. So actually what we're going to need to do here, especially because we're going to need this function for this stuff that we're going to be doing next for actually checking the collisions between the hitboxes. We're going to need this function anyway. So let us go into utils, actual utils, and we want to create a function that composites bbox. How do we want to do this? We want to composite the images relative to their bounding box per bounding box dimensions. So first thing we need to do is we need to find out what the overall size is. So let's actually tackle that one first. Find overall size of I'm going to say images, but it's technically bboxes. And now let's change that to bboxes. Bounding boxes. Bbox 1, bbox 2. And then this is going to return the minimum of... Actually, let me break it out just to... How do I want? Nah, I'm not gonna break it out. I take it back. Actually, AX 0, AX 1, AY 0, AY 1. Whoops. BX 0, BY 0, BX 1, BY 1. I will break it out. Like I said, BBox 1. Just to make it easier to read. BBox 2. And then we want the minimum of the top left corner. So that's going to be minimum AX0, BX0. Minimum of the AY0. Whoops. BY0. So that's the top left corner. And then we want the bottom right hand corner, which is the maximum of AX1, BX1, and max BY or AY1, BY1. There we go. Again, I broke this out to make it more readable, so you know what's going on here. We're pairing them piecewise, and then we're doing min, min, max, max. So that is that. So that will return a bounding box that is the overall size that we need. I'm trying to think at the moment of any ways that that would break. So I'm basically just imagining in my mind these guys, because the only way it really breaks, so there's two ways. One, B box is completely inside A box, or well, B box 1 is completely inside of B box 2, or vice versa. In that case, B boxes 2 would win out on all these. If B box 1 was inside B box 2, and vice versa, B box 1 would win out on these, so that doesn't break. And then if they did not intersect at all, then B box 1, let's say that's to the left, that would win. If they're parallel on the X plane, that would win in these two, and or actually would win this one, this one, this one. Well, we're parallel on the X plane, so yeah, this one, the Y one, and then B box 2 would win on this one. That's fine, and it works the opposite way too. Yeah, so that should be fine. Okay, so that gives us an overall bounding box size, and that gives us it in absolute coordinates is the other important thing. So even if this is instead of this being 0, 0, and then this one being 5, 5, you know, if this was 5, 5, this one is 10, 10, let's say, we would get the 5, 5 instead of 0, 0 up here for these first two. So it's not taking the difference, which is important. Important because that could screw other things up. So that gives us the find overall size of bounding boxes. And now we want to let's see. We want to find overlap of images. So actually, what we actually want to do, actually, is... No, we can do this way. Find overlap of images. Image 1, image 2. Actually, so we do need the B boxes. Okay. That was what I was stopping myself when I said actually. I'm trying to think of the easiest way to get those in here, but I don't think there is. So we are going to put those at the end, and we'll assume that they're 0, 0 if otherwise stated is how we'll handle this. B box 1 equals none, bbox2 equals none, and then we can fix that. So if not bbox1, bbox1 equals 0 0 image 1 dot width, image 1 dot height. If not bbox2, bbox2 equals 0 0. Whoops, no 0. There we go. Image 2 dot width, image 2 dot height. And now that we have these overlap of images, we can find overall equals find overall. Whoops, nope, that is not overall. bbox1, bbox2. So this will give us a large image size. So we can let's see. I1 equals image.new mode of 1, and the size will be, that can be a 4 parameter 1, right? Or no? No, that can't be a 4 parameter 1, can it? Shoot, it can't. Okay. I wanted to use, let's see. So 2 options here. One is to make these 2 images relative to each other to make our lives easier. The other way is just to make a giant bounding box and move the bounding box, move the offset on the bounding box. Let's see. Okay, so we should be able to paste with negative numbers, which is fine. So since we can paste with negative numbers, I think we can just do this. I think we can just take that overall size of the bounding box, use that as our size. So, and actually this shouldn't be overall size of bounding box. Find overall bounding box is what it should be, because it's not a size, it's just a bounding box that we're returning for that. And then we can use that size. So overall 2 minus overall 1, or 0 rather. Overall 3 minus overall 1. There we go. And color equals 1 because we want it to be white to start off with. And then that will give us an overall size. I1 dot paste image 1 bbox1 image 1. So now this is pasted wherever it's supposed to be on the image. Now again, this is going to be 0. This is going to have a 0 0 to whatever width. Okay. Sorry, I'm just doing some quick math in my head. No, that should be fine. Okay. This image may be pasted at, for example, -1 -5 or +5. Actually, no, I take this back. This is an issue. Okay. I was just thinking about the negative numbers, and it can paste in the negative numbers just fine. Our problem is that it does not it cannot paste the positive numbers fine that are outside the bounds of the boxes is the issue. So all right, here's what we're going to do. We're going to change this to overall 2 and overall 4 or 3. Overall 3. No, overall 0 1 2. Yeah, overall 0 overall 2 and 0, 3. So this image is going to be a lot bigger than we need it to be, unfortunately. I'd prefer that not be the case, but it fixes our problems is the deal here. So if I do this and the negatives are numbers, negatives are negative now, it shouldn't still, yeah, it should just be a lot bigger that way. Okay. This should fix our problems. It does implement an, let's see. Crap. I really don't want to create a massive image like this, but I also didn't really want to offset the images relative to each other. I guess that's probably what I should have done. I probably should have offset the images relative to each other. So let's see. Okay. We can keep this. We want to find the top left corner, the parameter that, or yeah, the number that is closest to the top left. Let's start with that. The numbers, I should say, that are closest to the top left, and then we'll offset both images by those numbers, and we should be good by the minimum of those numbers. Yeah, so that should be fine, and that should position them relative to 0, 0, and then we can move on with life. Okay. Again, what that's going to do is just going to keep this small. So we want minimum. So left equals, or left delta, I guess, equals minimum of B box 1, 0, B box 2, 0, top delta equals minimum of B box 1, B box 2. Okay, so that is for both images. The one that is closest, whose top left corner is closest to the top left of the canvas. And then we can go ahead and offset bounding boxes by that amount. And I guess I may as well, because this may come up again, create a function for that. Offset bounding box. Offset B box. And I typed out bounding box the other way. B box delta X delta Y. Return B box 0 minus delta X. B box 1 minus delta Y. B box 2 minus delta X. B box 3 minus delta Y. Just shifting it all over by that delta. Whoops. There we go. Okay. So B box 1 is now going to equal offset bounding box B box 1 delta X delta Y, and the same thing with 2. Alright, they are now both offset. I'll change these to match because delta X and Y make more sense than top and left, kind of, in a way. Alright, now these are offset so that their corners in the 0, 0. Now when we create the new image, that will only be as big as S is. So that should be good. Cool. Awesome. Okay. Crisis averted. So image 1 is now printed in this offset bounding box relative to this new 0, 0 right here. I2 equals image.new 1 overall 2 overall 3 color equals 1, and then whoops, and then image2 dot paste image 2 bbox2 image 2. All right, and now we can, like I was saying before, do the image chops logical and result equals image chops. Oh, did I do image ops instead of image chops? Oh, okay. Oh. We need both, as it turns out. Image chops dot logical and image, or I1, I2. So both of these at this point are the same size image. They just have the bounding or the hitboxes in our case positioned at different locations on the same canvas, and therefore we are now able to logical and them together to find the areas where they both exist. In other words, the overlap. And we can just actually return that. We will return that because that image will be the overlap, and then we can work with that overlap. All right, cool. Hitboxes. Do we need any of this? Oh yeah, that's what we were doing. That's where we're at. So the sprite image, now we need to get this. In order to use this function over here, let me open that back up. Where is utils? Let me slide him down to be closer. We want to find the overlap of the image. That's what we're looking for. We also need our sprites bounding box. So sbbox equals self.sprite.bbox. And then we're also going to need our bbox and our image. So self. Actually, I'll just do that inside of here. And return, because this will be the overlap. The overlap of the two images is what we're doing here with this masked square hitbox. So let me import that really quick. And we don't need this right now because we're doing that over in the utils. So I'm going to go ahead and move it out, and this module from stream animations import utils, and this is utils dot find overlap. So we got the S image and our image, so self dot image, or I should say self dot underscore image. Bbox is sbbox, and the bbox2 is self dot bbox. There we go. Okie dokies. Just thinking if there's anything else we need to do. I guess the only... Let's go ahead and try this at this point, actually. It's one of those things I would have preferred to run some test code a lot earlier. It's just that we did not have enough in place to get to this point in the sample code. So we can do this now, though. We are going to come up here. Let's see. Here's our load desk. So let's go ahead and we're going to need hitboxes, right? So we're going to come in here from stream animation dot sprite import hitbox. So we got the hitbox now. Let us do me and actually let us just do me for the time being. So hitboxes equals, and now we're going to want hitbox dot hitbox square hitbox. Actually let's do the masked hitbox. Actually we want this sprite is, oh shoot, sprite. Okay, so this does become an issue because this needs to be initiated with a sprite. Alright, hitboxes equals that. This is something I did not realize. Me.hitboxes.append. We're going to fix it like this for now. And we'll come back and think of a better way of doing this. Image is going to be hitbox.hitbox. Or actually square hitbox. Create hitbox, or create square. The width is going to be me.image. Or I guess get image.width. And the height is, I'm going to create a variable here, foot height, or I guess base height would make more sense. Base height, because my desk does, well, yeah, my desk doesn't really have feet. It doesn't actually have leveling feet on it, but base height. And we're going to call that 10 pixels to begin with. And we'll adjust it from there, depending. Actually, maybe it should be, nah, 10 is about 1/3 of the sprite height. So yeah, 1/3 sounds good. So 10 pixels. Alrighty. So, comma, height, yeah. Base height, alright. And anchor is going to be bottom left. Okay, so now me.hitboxes has a hitbox in it. Next thing we want to do is, I actually am going to raise an exception here because the only thing I want to check out first is to make sure that we are masking ourselves correctly with the mask square hitbox. So let's do, let's see. We're going to import utils. Do we have utils already imported? We should. Yeah. Okay, cool. Utils dot find overlap images. Me dot image. Me dot get image. Me dot hitboxes 0. Actually, let me just do this really quick. Cut this out. Hitbox, because we're just testing this really quick. We have a module named hitbox, so let's not do that. There we go. Much better. So me hitbox, me hitbox, me hitbox. So I don't have to do the 0 in here. Dot image. Actually, I take that back. The point of this is that me_hitbox.image is automatically adapted. Derp, right? Me_hitbox automatically returns the overlap. That's what I was trying to check, so we can just call that. Where did I put sample? Sample. What did we do here? Okay. That looks like that can be saved. All right. Dot show. So what I'm expecting here is we should have our actual mask is a 10-foot high square across, and then our feet are going to overlap with that, and that is going to be the image that we get, is the overlap between our feet. So we should basically have a negative image of our feet is what we should have. So let's go ahead and take a look at that. Hop back over here, quit this, clear, just to make it look nice, Python, sample.py, and let's go. Extra, but has no type annotation. All right, back to I wanted to run some more sample code before we got here, and we did not because we didn't have anything really to run it against. So this was inside of events. That's what it was. Events, utils, not utils. Just engine. There it goes. That should still be open, so let me look here. Field default. Oh, okay. This was supposed to be, let me minimize this for you guys. I had an equal sign right here. This was supposed to be a type annotation. That is that. So let's run again. Non-type object is not subscriptable. Self.location is none. Okay, that makes sense. That does make sense. We haven't put our sprite on the screen yet, so therefore he doesn't have a location. So let's me.location. Actually, I think, where was that getting called at? Me hitbox.image.show. Yes, so I can put that down here. So me.location equals 0, 0. Sorry, I hit Alt Tab instead of minimizing. I just added this me location line right here to set our location. And now we've got a Stack Overflow. That's excellent. A maximum recursion, I guess, rather. Maximum recursion. S image, blah, blah, blah. Calling that self.top left. Self.sprite.get image. Load. Self.image, self.top left, self.image.height in hitbox. Okay. So that is our problem. Let me make sure that's minimized. So this is looking for our image. I basically should change this to underscore. All these internal methods should be calling underscore, is what it comes down to. There we go. All right, let's clear and run again. This is the fun part of programming. Images do not match. Excellent. This is image2.paste, so that means that our size is wrong. So let's take a quick look at that. Let's see. Find overlap images. That's in utils. I2.paste was our error, right? And you guys can still see that because I did not minimize. Yeah, I2.paste. So it's saying image2 does not match bbox2. So let's go ahead and print image2.size and bbox2. Actually, we can do image2.get bbox. Let's run that, and the print message. Oh, never mind. I take that back. Let me double check. Minimize this for you guys. Let me double check the docs really quick just to make sure get image or get bbox is what I thought it was. Get bbox. Nope. Get bbox. Okay, get bbox has no underscore. Good to know. Again. All right, there we go. So none, and then 0, 22, 32, 54. So image 2 does not exist. Image 2 is none. Which means that I got to come up here to hitbox. This is calling self.image. Self._image should be already set. Let's check. Self._image equals image.convert. So let's check the get square image. Get square image returns an image. The width and height. So unless return this new image is returning none for some reason, then we got a problem probably in sample. So let's take a quick look. Let us copy this out. Whoops. Print that. So that's the square image that we're expecting to get. And I'm just looking at it really quick just to see if there's anything that I think is wrong. I don't think there is. So next we can do we can print me hitbox dot image underscore image to check what it is on the hitbox itself. And then if that's not going right, then it's somewhere over here on what you get on the find overlap of images is something going on over here. So which it doesn't look like is the case, but we'll find out. So we did print out 2 images here, but all of a sudden self._image becomes none right here. So let me minimize this. Let us go ahead and print our parameters right here just so that we know what we're looking at. So this is the stuff we're sending into that utils function. I'm going to go ahead and delete the other prints and sample because we know those look right, I think. Let me open that back up. 32 by 10 images. Yes, 32 by 10 images, and they're mode 1, so those are correct. Those are what we're expecting at any rate, is what I mean to say. So let us run this really quick to see what the parameters are there. That is 2 images and 2 bounding boxes, but all of a sudden we end up with none. So we minimize, come back over here, and continue chasing the rabbit. So utils, wrong utils, this utils, find overlap images. So here's our image 2. So do we set image 2 as anything? Oh, image2.getBbox. Image2.getBbox is none. Is returning none. Actually, let's do this then. And let me take another look at that bbox. So the bbox we're passing into it is 0, 22, 32, 54. 54 is not correct. Okay. That is a problem with our offset bounds, I think. Let me open that back up. 0.22 is correct because that's 10 down, and then it should be 32 is what it should be. Instead we got 32 plus 22. So where is our offset here? Offset bounding box. Let us print the delta x delta y. Print. Let's print that, and then actually let's also print bbox 2. And we'll clear to get a fresh page. And okay, so the bbox 2 coming in is actually bigger than it should be, which means that is not the problem. Let's come back here to hitbox and self.bbox. Let's check that guy. Self.image.width. Whoopsies. There we go. Height. Hopefully that fixes the problem. A little typo there. And it does, except for the fact that I do not see anything on my screen, and I should see a pair of feet. So, we are going to go ahead. I didn't show you the image, but that's because it was completely blank and a waste of time. It was a blank image is what we got back. Let me just check for prints really quick. Whoops, that is not what I wanted. Isn't there a button here to only show pages that are open? All right, whatever. Never mind. Not dealing with that right now. Delete that, and let us go ahead and I1.show, I2.show, and this should show me a square on I2 towards the bottom of the image, and then the negative of our character, just the black, the black pixels of our character. So let's run that. And that is not what I got. I got all blanks. So something is going wrong here. Color 1 should be white. Let me show instead image 1.show and image 2.show. Actually, I guess I can show these down here just so that I keep all the outputs together. Let us see. And if I don't, within the next couple of minutes, I did minimize that for you, I apologize. If I don't figure this one out in the next couple of minutes. Okay, that's interesting. So let's open up the pictures for you guys. And where's the one you're looking at? Close this guy, close this guy, close this guy. I actually don't see the one you're looking at right now. I guess he's all the way back here. Okay, so here's our image 1 and image 2. So there's the image 2 is what you're seeing right now. And then if I close this guy, you should get image 1. So two things. One, this dithering right here, I actually forgot I need to set as none when we do the convert. So I'm going to fix that, but that shouldn't be the problem. That shouldn't be our problem. However, it does show that we do in fact have images, which is good. It's just the pasting the images onto the old images is a little bit of a problem. So let me minimize that for you guys. Sorry, apologies. Down in somewhere, hitboxes, convert 1, image dot dithering. Let me check the docs really quick. Dot convert dither should be yeah, it should be dot dither. Let me check where that's at. Oh, is that underneath image chops? Okay, I think that's under image chops, which means that we're gonna have to import it. Image chops dot dither. Whoops, did I not just see that? No. Okay. Constants. Where are we at? Let me make the documentation full screen really quick. Oh no, it is image dot dither. Okay, so why didn't it come up last time? Let me delete this guy because we don't need him. Come down here. It should be image dot dither. Image. pl.image.dither. Yeah, I mean, this is supposed to be correct, but for some reason the is not picking that up. Well, that will fix our image having dithering at any rate. The next question is, where are we pasting this in then, if that is the issue? So let's go ahead and, actually we printed bounding boxes before, so we know exactly where we're printing this. I'll print them again, just in case. And I'm gonna comment these guys out really quick, just because I don't want to see them. Print bbox1, bbox2, just to make sure those are getting printed where we think they are. And print I1, I2, just to see what those look like. And that's not show obviously, but alright, so the B boxes look correct. The size on the images look correct because they should be 3232, so that looks correct. They are at different memory addresses, so I'm not somehow getting them duplicated. So if I do image 1 and image 2 show, this no, that was black. That was black still, so that was correct. So let me look at these guys again, because these guys should have these images shown in them, which was not happening. I was getting white screens. Oh, you know what? Maybe because it's a mask, maybe I need to invert this. Let's see. Invert. Yeah, okay, that is an image chops function. Or actually, nah. Color 1. Let me do this really quick just to see what happens. I'm curious. Okay. So dither did not work is the issue. Let's go ahead and hop you over to the pictures just so you can see what I'm seeing. So there's us. Obviously the dither did not work, which is a little bit odd because I recall it working before. And this is image. So this is I1. This is I1. And if I close this so you can see the next one, that's I2, which should not be, right? Because we should have a black box across the bottom. And then this is I3, which is obviously a black box because it's logical anding together. Actually, it's logical anding together, so it actually should have the inverse of the whatchamacallit. I'm really kicking myself for not having that code I wrote up. Again, I prepped for the stream on a different computer, and I was like, okay, this is simple enough to get done. So, all right, well, that is what it is. I'm going to get the I don't have access to the computer right now. I did it on break at work, admittedly, on the work computer. So I do not have access to that computer at the moment. I'm going to, tomorrow's Monday, I will go ahead and pull that code off my computer at work and figure out what I did differently at work that this is not working. Because again, I ran this code at work and it worked correctly at work. So, all right, a little bit disappointing. We didn't actually get to the collision part. However, actually, you know what? Let's go ahead. This just needs to be fixed later. I can tell you exactly what needs to happen to actually get to collisions. So this find overlapping images, right? It will be completely white. The image will be completely white if there is no overlapping images. That's the end result. It will only be black on the pixels that overlap. So what we can do then is let's see. Engine, utils, find collisions. All right, here we go. So we have the hitbox and the hurtbox. I'm saying hitbox and hurtbox, but hitbox 1, hitbox 2 that get passed over here. These are actually hitboxes now. And hitbox, I'm going to call it hurtbox just for the heck of it, but not actually a hurtbox right now. We'll find the collision between those two. And this will be utils dot, do we not have utils in here? This module from stream animations import utils. So utils dot find overlap of images. And this is now again hitbox 1, hitbox 2, and this will be hitbox 1 dot image, hitbox 2 dot image, hitbox 1 dot bbox, hitbox 2 dot bbox, and that's going to be the result. And then if the image is completely white, if there is no overlap, then we should get no bounding boxes because the image is completely white, so there's nothing to bounding boxes. So we can return bool result dot get bbox, and that will, either we'll get a list of overlapping areas of the two images, or we will get none because there is no bboxes because the image is completely white, and that will be our find collision. So if so if it does find a collision, does find overlapping pixels here, that will return true here, and then we can return false to the collision function, or rather to the callback for movement. Then again, the return callback, the callback right here. Let me just pull it up. Canvases, the result will be false, and then we'll return and we will not execute move, and that is all of it. So that's how close we were. Again, the function is now complete. It's just I'm not entirely sure what I screwed up from memory on this one with overlapping these guys. I guess I will find out. So I will get back to you guys about this one on our next programming stream for the animation thing. Thank you so much for your patience. I hope you have at least gained some, I don't know. I hope you gained something from this one. I hope it was maybe entertaining at the blunders at the very least, and otherwise taught you to come into these things with a little bit more of a plan. Otherwise, just because obviously somebody forgot to plan ahead and bring his code home with him from work, and therefore did not have code to double check to make sure he knew what he was doing, and just assumed, you know what, it was easy enough to do at work. Took me all 10 minutes. I'll be good when I get on stream. Obviously, I was not good when I got on stream. So, lessons learned. We are basically there. Again, it is just fixing this code right here to properly overlap the images, and then it should function. Knock on wood. Knock on wood, it should function just fine enough as soon as we're done there, and that will be the last of the collisions. So do not expect another collision stream. Next stream, I'll go over what I had to fix here, but otherwise, that stream will be pathing. Well, basic AI and pathing was the plan for the next one. So my basic AI was just a wander function, so my character would come up with waypoints he wants to get to. The pathing, we were going to implement A star because A star is relatively easy to implement. And then we would have the AI wander from my desk to the printer to other random points on the screen. And that would be good enough for now. And one of those things, in theory, when we get more stream assets, we could have my AI or my little character, my little pixel character, doing stuff instead of just wandering around the area. So that's the plan moving forward. As always, I hope you guys, thank you for watching, first of all. Thank you for watching, and I hope you guys have a great and wonderful day, afternoon, or evening, wherever you're in the world. And I will catch you next time.